Great. So thank you, everyone. And yeah, I'll be introducing or talking about ontologies. My name is Abdullahi Kawu, and I'm part of the technical team. So please do not be overwhelmed by this. It's just a summary, but you see why this is useful. So look at ontologies, how that in relation with vocabularies, what is cause and how that is used for vocabulary creation, what is OWL or web ontology, and how that relates to ontology generally, and some methodologies around that. So when we say ontology, it's a term that represents knowledge that define concepts. So concept could just be anything in the world, right? And this could range from name of things, places, um, events, activities, but it's also include properties. So this can mean if you have a car, a property of a car could mean the color of the car, for instance. So and certain things around that. Then also relationships. So here it's referring to that between concepts, there is always some type of relationship that exists. So, representing all of this knowledge is what ontology seeks to achieve. Or when we are developing ontology, we are trying to create a formal representation of all this knowledge um, around the concept that we're looking at and the properties around them and the relationship. So, and why is this important? Because they serve as semantic data models. Semantic is, to keep it simple, it just refers to um, the meaning of a data. So, as with everyday living, certain contexts, certain concepts can change meaning in the context they are used. Okay, so and that's why we need to understand what is the semantic that some concepts uh what's semantic behind some concepts and hence the ontology also. So it's important because it helps us process knowledge, but also share and reuse. So uh, I always give this basic example to students. Please excuse me. Let me. So, okay. So, can you hear me? I think I'm hearing some background noise. Okay, thank you. So, I like to always use a simple um, illustration with our dictionaries, right? So, a dictionary, whether English, France, or any dictionary, gives us an idea of meaning of words. So when you look at that, and a simple dictionary will just give you a word and what it means. So basically, it helps you to know if this word is used or is said, this is what it means. Similarly, we use ontologies to structure data so that when we're sharing data, when someone else sees that data, they immediately can understand what the data mean in the context we're using it. So that's why we use or ontology in that sense. So in terms of the component, if you are looking at the screen, these are majorly the four pillars that ontology sits on: concepts, We'll look at what that means, relations, and instances and axioms. So some of these have subcategories like what is taxonomy, associative. We'll look at this a bit in details. So this is a typical example of a simple, really very basic uh, ontology. And here you can see three concepts are represented here. There is a concept around organization, around employee, and around the country. And between these three concepts, there is a relationship. Okay. There is also properties. So a country, for every country, there's always there. Every country has its currency, right? So that is a property of a country. A country has a language. That's also a property of a country, or languages, as the case may be. Those are properties of a country. So what this means is if I share this ontology, or I'm using this ontology, I understand that there is a concept called country, and it means, whatever meaning we want to give it. We'll talk about when and how to state that meaning. And then it also have this property. So this property called currency, this property called language. And that will mean we can, for instance, share information about the country itself, the currency, and the language in the context of this ontology, right? So this is what ontologies look like. Similarly, for organization, an organization will usually have its headquarters, maybe some code. This could mean maybe address or something. Whatever you define, the whole point is you will have a clear definition of what concepts will be, what are their properties, and their relationship. So three things. Never forget classes, which refers to concepts, by the way. This is the formal name you give concepts called classes, but it's more or less the point of concept. Then we have relations. Okay, this is also um, a kind of concept, but it's talking about relationship between one concept to another. So, for instance, an organization will always reside in a country. Okay, so you see here we're saying the relationship between organization and a country is that it is in the country. Okay. Conversely, a country is home to many organizations and, of course, to this organization. So you see, these are all languages we use every day. So, for instance, the World Health Organization headquarters is in Geneva, Switzerland, for instance. Or we say Vodan is uh, headquarters in Brussels, for instance. So all these are, specific properties that shows the relationship between a country in this concept, or one concept to another in this context, a country and organization. Similarly, here you have employee and organization. So an organization is usually the one that employs an employee. So you can see that relationship, but an employee is part of an organization. So these are all descriptions. So these are all things we can describe about our data. Why are these important? Maybe we'll talk about this later, but basically so that if we need to know which organization an employee is in our data, it's a knowledge graph thing. We're able to query it because we can just query um, maybe the concept, maybe the relationship, and sometimes the properties. So all of this, you know, all combined to give us the data we're looking at. So without repeating myself, talk about classes, uh, which are more or less, again, we can see in this example, if we say a class represent entities in a domain, concepts within a particular domain. We give example with disease. So disease is a concept, symptoms a concept, drug, all these are part of, for instance, the medical ontology. You see, you don't find this, for instance, uh, say in humanity ontology, if there's something like that, or because again, it's about the domain, so it has to make sense to what you are, you know, the domain you are working with and in. Individuals refers to example of that. So if you take a concept called disease, the example will be diabetes, for instance, malaria, for instance, syphilis. So all these are terminologies we use in ontologies, but they just mean examples or instances or members of particular concept or class. Relations is the short for relationship also, and describing the connection between one concept or class to another. Okay. Restriction, we talk about restriction because in terms of formal representation, we need to assert some kind of restriction. Otherwise, um, again, we'll lose the point of the ontology if just anything can be shared in the context of a particular ontology without specifying the restriction. So I give you an example. Let's say the age of, okay, let's say the date of birth of a person. Okay. So here we expect one, the date should be a date period of time. Um, should be in a particular what we call data type, maybe date format. Um, maybe also, yeah, let's even stop at that. So the point of restriction is to say we specify that this is the condition that should hold through for this data to be accepted within the ontology, meaning a person cannot just share a name as a date of birth or share some other information, some other type as a date of birth. So these restrictions are important. There are things we call cardinality also as part of restrictions, which is saying how, what are the different, variety of ways a date, for instance, can be represented. A date of birth could be represented as a string, could be as an integer, for instance, if you're thinking of it as age or things like that. So this is where those are made um, possible. So attributes, again, they are properties in this context. So remember the property talk about a country, the currency, the language. So all these are what we mean by attributes. Axioms are some of the logical assertions. So what we mean by axiom is the formal knowledge that is derived based on all this information. So, okay. So for instance, as in this example, we expect that every patient that have diabetes, that their blood pressure should be above a certain level. So we can easily query that patient um, with diabetes with this blood sugar level, or we can make inferences that patient with this blood sugar level are diabetic. So, and that is one major use of the ontology to enable us derive knowledge, to enable us yet uh, to make assertions, okay? That if this and this is true, then this is also true, which you don't get really with maybe your normal database systems. Now, you may have had ontologies and sometimes vocabularies. How are they in the context of, ontologies? First, you should know that Um, it's around the semantic, what we call the semantic spectrum. So a full-fledged ontology is really a formal description of all these things I've mentioned, or majorly, if I would limit it to three, four things. So it's around we have a concept, we have a relation, we have properties, okay? And we have logical axioms. So if we get a system or kind of a formal representation that is in that holds true for this, then we have an ontology. However, down the line, there are you know, there are formats or formal representation that are not necessarily ontologies, but they can be considered part of an ontology spectrum. So, as an example, a list, just imagine a list of anything, maybe a peer, a name value system where you have, for instance, um, as an example, let's say you have a list of people. Okay, so you have one numbering, you have also name of people. So you can see that there's some kind of information, there's some kind of representation, or you have like we are building using you guys are working on control vocabulary. That's also a sort of list and is a kind of an ontology, but the semantics around it is kind of weak because there are levels or there are things you cannot assert, um, you cannot make some of those assertions like you will do in a full-fledged ontology. So you are not able to really run axiom as much when it is just control vocabulary. So it still gives you structure. It still gives you a level of so you develop concept, no doubt. You work with you create relationship. But again, the relationship you create, and this is where it's interesting, they're largely predefined in for control vocabularies. But in the normal ontology, you can create user defined on relationship. You can also um, expand on existing relationships. So we said in general, control vocabularies could be simple list of terms that you use for categorization with less formal semantics around it. We also have what we call taxonomies. Taxonomy, for some of us that have science background, we understand this from biology. We use that to categorize, you know, animal, plants, and to say maybe we're all from the plants, this Homo sapien, and then you go from there, you have Homo habilis and all of those classifications. So, given that kind of sense is what we also do with taxonomy here, where we create hierarchies and based on a kind of relationship we call the is-A relationship. Is-A is just saying this is a type of this, right? So, for instance, mammals are a type of animal. So a mammal is an animal, you know, a bird is an animal, okay, and things like that. But of course, when you go down the line, you again have more kind of hierarchical structure. But ontologies are more advanced because they provide predefined relationship, formal logic, and all of that. So when we talk control vocabularies, we're also looking at, um, like I mentioned, um, list of terms, but that make meaning. There's also some relationship that are usually there, but a lot of it predefined. For instance, you can decide to have synonym of a term. So maybe you can have boy and you put synonym as male, for instance, girl synonymous female. So all these are possible within a vocabulary. You can also create hierarchies, but again, the hierarchy you create are around whether this is part of a bigger term, okay, or it's a narrower term. So you always have a term that is, you know, that encompass other terms and then other narrower terms which you can define. So some of this you see when we come to the practicals of this. But I'm just saying when we talk of control vocabularies, put in mind these four things, please. The hierarchy, that means, as an example, animal is a broader concept, but all of these dog, cat, and birds are narrow concept. But when you look at them, they all belong to the animal, category. You also have synonymous relationship, like I explained with the male and female example, or the male and boy example. You can also say there's synonymous relationship between terms. So especially sometimes how we use them. So some people call it hypertension, some people call it high blood pressure. Um, and sometimes it's written HBP. All of this can be defined as concept, but related to one another through this synonymous relationship, which we will look at. We also have related term. Here, the difference between synonymous is one can replace another, whereas for related term, not necessarily one replacing another. They may have components. So climate change is a part of global warming, but is it the only reason for global warming? This may not be true. So just showing that there's a relationship, but not necessarily a synonymous relationship. It could be. So there's also the part whole relationship, you know, where you can say one concept is a part of another. So my leg or your arm is a part of your whole body. So you can create a relationship on that basis. So technically, this is what they kind of look like using scores. Of course, there are many formats for representing some of this formal representation. But for vocabulary and taxonomies, we use scores a lot of the time. And it's the framework for representing vocabulary and taxonomy. It's also built on RDF. So RDF is a larger framework that have scores as an example, total, excuse me, all of this. So we'll see all later, but just to say we use scores to create vocabularies and taxonomies. Again, we have concept, we have labels. So generally, when you look at this, you realize here we call them prefixes, and after that we have concepts, and for each concept you can see there are some information here. So these ones are called label. This pref label is referring to preferred label for this concept. So what it's saying is if this concept is to be used in a system that is user facing, then the label that can appear is this. So it could be a little slightly different from the concept name, but just saying that that is the preferred label. There's also alternate label, which is saying this can replace that. So now here you see at EN, here is referring to the language. Okay. So again, in ontology, we can work with language. That is by specifying that a concept can be represented in multiple language. So here in this case, English, um, for animal, I think animals for in French, that's how they call it. The alternate label for creatures is also like that. So we're saying for the concept of animal in this example, you can see that the preferred label is animal, the alternate label creature, meaning animal and creature can be interchanged. You can also have it in other language, not just French, it could be German, it could be so, and this is important because if we need our ontology to be global, truly global, meaning others can reuse our ontology in their own local language without necessarily having to, um, modify any part of the ontology if we specify this preferred or alternate labels and include the languages that these are. So the same goes for this ones, okay? The semantic relationship. Of course, we explained that in terms of vocabulary. Now, this is a little slightly different from what we have in ontology. We have basically two kind of relationship. We have the hierarchical, talking about the broader and the narrower. We also have the related. Okay, so when you see scores broader, you are talking of the broader concept. So in this, an example will be animals, and the neural concept will be dog, cat, and bird, like we gave an example. So, but also here you can see mammals will be said to be animals, but there are other kinds of animals, so those can also be under as narrower concepts. But again, the concept remains animals, but you see we're specifying the narrower type of concept. So this is how it's represented in the file, but we'll see using the Excel how we easily specify this to give us this output. Yeah, this is basically similarly what I've explained earlier. Then we have documentary notes. So just to quickly put us on track, you see I've discussed concept labels. So concept, we specify concept by first we specify the prefix. This is usually your schema name and URI. So we'll talk about this a bit, but I'll explain that. But we said um, preferred label is what we use to specify the label, and the alt label is another name, more or less how we specify the alternative label that this concept can take, or alternative or synonym, like we talked about earlier. Um, this is also in another language. So this is more or less repeating the same thing, but providing the different in another language. So, for instance, some of our colleagues that are in Francophone countries, they could easily modify any of the vocabularies developed in English by providing the preferred label in French and the alternative label. We also have documentary notes. So there are different kind of, so here I'm just pointing to some of the keywords we use to create the vocabulary, from technical point. But we'll see that with Excel, you can already easily see some of these things. So I will not talk about all of this for the sake of time, but particularly definition. So remember when I was talking of the male, the boy, um, we said just like in a dictionary, there's always an explanation of what a word is. So similarly, for every term or concept, we use course definition to define what that concept is. So if you look at this example, we have cat. So you see the definition here is a small carnivorous mammal with blah, 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 a retractable claws. So So anyone using this vocabulary have an insight of what a cat is in this context, okay? So again, you see that we use cause definition just under the concept, okay? And then we define what that is. So in relation to cat as a concept, this is its definition in this vocabulary. I hope this is clear. You can also give an example. So if we said this card, we can have an example, scores example, and provide an example of a cat. Maybe, I don't know, a name that people know, which refer to a cat, you know. But again, you should be careful not to have alternative or label as an example. I mean, it's kind of your call, but you should just make sure that distinction is there. Then concept scheme. This is used for defining what the control vocabulary is. So at the beginning, I think I've made this is not the particular image that's supposed to be here, but when you are creating the vocabulary, there are schemes that refer to the class which the vocabulary is related to, right? So we have the concept scheme. We'll see this particularly. We also have, some other properties that come from other vocabularies like the Dublin core. So that we reuse. As part of your assignment, I think you are asked to map concepts from what you have to what exists. This is very important in vocabulary and ontology creation. That is, we're trying to ensure that concepts are used as much as possible, both within the vocabulary, but also outside. So within gives you an example is where we talked about uh you know the boy male. You can still define boy as a concept, male as a concept, and kind of create a relationship between them. There's also some kind of mapping. But when we talk about strictly mapping, we're referring to establishing relationship with outside, concepts that are known already outside. So um, this example is given to show that where you have, for instance, we have a fruit type vocabulary, right? In this vocabulary, we have also another vocabulary from fruit category. So these are two types of vocabulary. So there's no doubt that there could be some match between both. So here we define two kind of fruits in fruit type vocabulary. Imagine person A who has fruit type vocabulary. In his vocabulary, he defines apple as a concept, sorry, and banana as a concept. But in another vocabulary by person B, he has only defined or is interested in defining tree fruits, like the category of fruits. So whether it's a tree, fruits, or it's a tropical fruit. He wasn't interested in the name of fruit. He's just interested, or is this fruit tropical or is this fruit a tree? So how can we, map them? Because in the end, we want to see tomorrow if we want to query if, for instance, someone is using our vocabulary and they are saying, okay, tell me about tree fruit. So, and the person has only the fruit type vocabulary. The based on this mapping, because he has that mapping done, they will get a response because they will get um, response because they have already mapped, they have, connected their concept to the fruit category vocabulary. So it's now easy to say, okay, yeah, you If you're looking for tree fruit, then we have apple, for instance. But how do you do that? That's the last bit here, where you specify, apple, and then use this cross match that is saying that apple is a kind of tree fruit. So you are saying exactly it means similar thing, or um, it's exact thing. Okay. And there are other kind of matches. There's close match, broad match, narrow match, and related match. So generally, if you are building vocabulary, these are like the steps. You define purpose, scope, actually the time domain of the vocabulary. Are you talking about vocabulary in the health space, like Vodan, or are you talking about vocabulary in the humanitarian space, like the case of the human trafficking? So it needs to be clear because you don't conflate the two, except if there's some kind of relationship that, so you need to just clarify. So in our case, it's quite clear. There are, two teams working on one, the Vodan, and then the humanitarian. Then we need to identify the terms. And I think you have all passed this assignment, which is defining what are different terms that will be helpful in the domain to describe concepts related to what we are working on. So in our case, for instance, Vodan, talking of ANC, so concept related to, antenatal care, mothers, the visit, and, all the concept as, for instance, our reference document also is the antenatal care register, so these are how the steps that are required. Then we go on to define the term. So we have the register, we clearly specify, okay, this is what the term is. That's the point we also specify the synonym. If there are uh, any terms that are related, and we clarify and ensure they are consistent. We also identify the ones that are external and, link them together. And also we go on to organize the vocabulary. So here it could mean you develop the Excel sheet and then structure it based on this course model. We'll see this very soon. Then when all this is done, you also test it. We'll see this quickly, then publish and then refine. So it's actually an iterative process because sometimes you see that you miss certain concepts which you need to add. Sometimes you find that people point to clarity in the definition you put, which you need to work on. So all these are the process. So to do vocabularies, there are many tools out there. I'm sure you have been introduced to OpenRefine. But I'll be talking of Cosplay, okay? We use Cosplay to create vocabulary, but also to validate it. I know some of you may have had a go at it. If you have been to a website like this, I think you are cool. That means you have had, if not, going to this link will get you nearly there, not there, because when you click on it, you're actually taken so maybe I will just go skip verification. Let me see. Yeah, so this is, are you seeing my screen still? What? I didn't know I had, hello?
Yes, we can
We
see
are
your
here.
screen.
I was about to warn you of the time.
Yeah, you'll have done so. Okay, so maybe I'll just round off in 5 minutes. Sorry, I didn't know I lost time, control of the time. So,
And Abdullahi, could you paste that URL on the chat?
yeah, absolutely.
Please, please.
I think, unfortunately, I don't know if we'll have time to demonstrate. Sorry,
I really wished you to demonstrate.
Yeah, yeah,
so
I would
that
say,
we get
I don't
the
know.
process.
Let's see, let's see. Sorry about that, everyone, because I thought I had more time than that, but apparently not.
But Kawu, you can also just repeat some of these concepts next week because there are a couple of questions that needed to be clarified.
Okay, so maybe we'll take some parts next week because I think I will just finish vocabulary part. There's also the ontology, so I'll just quickly. So if you open the website I just shared, there's somewhere you need to click. I will just show quickly. So if you go to scores here, yeah, I want you to see this, but not now. That's not even where I'm heading. So if you go to Scores Play website, you see some of what what I will quickly talk about. So you have different templates. I know you are introduced to probably the last use case for template, which I'll briefly talk about, but let's start from the simplest to make it really easy for you. So the simplest, so this is the same thing you had seen earlier. The simplest is this. So we use this Excel template, for instance, to create vocabulary. And all you need to do is replace the content with the content of or the concepts that we have talked about. Yeah, so if you remember, we talk about the scores preferred label. That's simply like the name of the concept. We talk about scores definition. So what does it mean? Narrower, does it have a narrower definition than, So for instance, this last one will tell you what I mean. So when we say weekend, it's a concept in itself, but under it, we have Saturday, Sunday. You see, Saturday and Sunday are concepts, but they are narrower under weekend. So this is just an illustration of what that may mean. So usually you specify your own, namespace or using a URI. Like Vodan will have vodan.tot Africa and all of that. And the title, what's your ontology is about, this title. Description is similar to this definition, like what is this ontology about? This is a simple ontology about the days of the week, okay? So you can see the days of the week. The title is weekdays, okay? So, but the more advanced one have a bit more. Here, this is also where especially you need to use prefixes or namespaces outside. You see, in the previous example, we are largely using only your namespace. We're not importing anyone. But here, for instance, we're trying to use the Dublin core and also this other one. So if you need to import and use, or like we show earlier, where we have talking about this, sorry, where we map concept, you see here, if you are mapping, you need to specify the prefix you are using. So that is that. Then we have similar, other rules of this. So we'll take the practical next time and also talk about all and ontologies fully. Really sorry for running over the time. Yeah, thank you. So prefixes are namespaces like other ontologies that. So there are some that come with every vocabulary. The discourse itself, there's the W3, there is also the Dublin core. So if you look at the example we're showing here, so let's say the line row 4, prefix DCT. This is if you look at this URL, this is showing a URL that is outside this document, more or less. Okay. That shows if you are to open this, sorry, if you are to click this or copy this to open in a web browser, it will take you to information about a vocabulary on Dublin core terms. So there are some kind of terms already defined under the Dublin core that we can reuse. Okay, such term like description, you see all these ones, title, description, creator, contributor, all these are Dublin core terms, okay? So this DCT that you have specified here in this column B4 is used as the abbreviation that will be used to describe all this, and even within, the other rows. I don't know if you are getting me. So if you look at PAV2 here, it was used to as for created on, for last updated on, and things like that. So if we have any other ontology we want to use, we'll create a prefix row, specify a short a short name for it that we can reuse here and provide the URL that leads to its description. Okay. So yeah, we'll stop here. Sorry for everyone for going over and above the time. I was really trying to be more explicit and to make the practical easy, because then we'll be able to, but we'll take it maybe for half an hour next week. Thank you.
Yeah, and Kawu,